lab 3 for physics 2, magnetic field of a bar magnet. So first of all, in this lab, we'll be observing the magnetic field of a bar magnet in order to understand the relationship between magnetic field and distance. The system is the bar magnet, surrounding is Earth and everything else, and my main results are as shown there, and obviously we'll go over that more later. So basically these are all of the equations and physics concepts that we need for this lab. Most of it is just magnetic field related, and then this is the off-axis magnetic field equation. This is the equation that we will be putting this into in order to find this value. And then this is the perpendicular and parallel magnetic field equation. This is my magnetic dipole moment is what we're finding there with this. So for this experiment, basically the procedure is that we use this app in order to find the distance, certain magnitudes of the magnetic field in this way here. And basically what we did was find a few distances with certain magnitudes, like the 20, 70, 120, 170, 220, and then found the perpendicular distance with 100 magnitude. And then the same thing, we went the same over and up in order to find the D there. And then we'll talk about this in the next slide, but this is the equation that will let us find N and K. So here you can see that based off of this graph and my equation here, N I found to be negative 0.4844, and then with that being with R is 1 meter, and then K negative 0.795. And then when you put these two equations together, so input this with this, then you can find that switch this around to find the magnetic dipole moment, which I found to be this. And the observations I had from the list were, when your phone app thing is far away from the magnet, it measures as near 0 magnetic field in the x direction, and as it gets closer to the magnet, the measured x is increasing. And then these are all of my values for everything with my found magnetic field net there. So for the code, basically the main thing was just editing it to put in the equations for the magnetic field off the axis, and then the magnitude, and creating the cylinder and inputting what I found from the experimental data into that to make it put out stuff. And then this was just kind of like playing around with it to see how it would look in the thing to make it look okay. And this was my perpendicular distance. So this is what it looked like, and this is what my two values were, the computational and the experimental, and the percent difference. So basically the error for this is mainly an issue of personal error for sure, and because the model itself is pretty straightforward, just like a magnetic field is going to work how a magnetic field works mathematically in the same way that it does in real life. So the computational shouldn't be too far off if the code is right, but definitely if you don't have your phone in the right thing, or you had too many electronics or other things that were in the way, then it makes it really easy to mess up your data. So for the last questions, if you hadn't oriented it to compensate for the magnetic north and laid it out in a random angle, then the x value of the magnetic field would be off by however much it was when it was laid out randomly, because we did it with, that at 0. And then it would also affect the y value because it wouldn't account the same, if you're in the north position, you know what the y should be. Then for the second question, if you were to stick two of them together, how would the experiment run then? basically the magnetic field would be more powerful and stronger, as there were two magnetic fields present, and you could probably estimate it to be about double with superposition, and the distances would decrease as the double magnet would increase the field closer in, as it'd be stronger, 2 times stronger. So yeah, that's the end. Thanks.